Right now, TRAPPIST-1G is still doing something in total darkness that NASA's own instruments cannot explain, and the team behind the James Webb Space Telescope has no way to account for it. They have been staring at this planet for months, and what they found on its dark side is the part they are afraid to say out loud. But here's what nobody is telling you. 40 light-years from Earth, there is a planet almost exactly the size of our own. It orbits a star called TRAPPIST-1, a red dwarf so cold and dim that from the surface of TRAPPIST-1G, it would look like a dull orange coal hanging in a rust-colored sky. Not a sun, an ember. TRAPPIST-1 is only 8% the mass of our sun. It burns at roughly 2,500 degrees. Our sun burns at nearly 10,000. And TRAPPIST-1G sits far enough out that it receives less than a third of the energy Earth gets from its star. This system stunned the world in 2017. 7 Earth-sized rocky planets orbiting one dim, cold star, 7 chances at water, 7 chances at something more. Scientists placed TRAPPIST-1G right at the outer edge of the habitable zone, the narrow band where liquid water could theoretically pool on a surface. The headlines called it humanity's best shot at finding life beyond Earth. The scientific papers were careful, measured, restrained, but the implication was electric. But TRAPPIST-1G almost certainly never sees its own star, not from one side. Tidal locking. One face permanently turned toward the dim red glow, the other locked in total, permanent darkness. Scientists built the models. They ran the simulations. The lit side barely warm enough to melt a thin sheet of ice. The dark side plunging toward negative 100 degrees Celsius. A frozen, airless, dead world on the night side, cold enough to trap any remaining atmosphere into a frost on the rocks. That was the consensus. That was what the physics demanded. That is not what James Webb found. When Webb captured TRAPPIST-1G's thermal signature, reading the planet's heat as it slipped behind its star, the numbers came back wrong. The dark side was warmer than the models predicted. Not wildly warmer, but enough to break the simulation. Enough that the research team flagged it. The planet that was supposed to be a frozen rock in permanent night was radiating heat that its star simply cannot explain. But here's the strange part. It shouldn't be possible at all. For a tidally locked world to move heat from its lit side to its dark side, something has to carry it. A thick atmosphere, circulating winds, pressure systems routing warmth around the globe. But red dwarfs are violent. TRAPPIST-1 erupts in massive stellar flares, blasting high-energy radiation across the entire system. That radiation strips atmospheres. Over billions of years, it should have scrubbed TRAPPIST-1G clean. The assumption, peer-reviewed, published, widely accepted, was that any outer planet in this system would be a bare, dead rock. Airless, exposed, frozen. Authorities signed off on that conclusion, and yet the heat is moving. Here is what makes this deeply unsettling. That warmth may not be coming from the star at all. The heat could be coming from inside, geothermal activity, a hot churning interior still pumping energy upward through the planet's own crust, which means TRAPPIST-1G might not be frozen and dead. It might be geologically alive. Quietly, persistently, generating its own warmth in the middle of permanent, total darkness. 40 light-years away, right now. If that's true, then 2 possibilities open up and neither one is comfortable. Either this planet held onto an atmosphere against the violent flaring of its own star, surviving something it had no business surviving, shielded by a magnetic field or geological luck we haven't measured yet. Or it doesn't need an atmosphere at all, because the engine is buried inside. And if the engine is internal, this is not a special case. Every tidally locked planet we dismissed as too cold, too dark, too far from the light needs to be reopened. Our own solar system has the examples. Europa, Enceladus, Titan, all sitting in permanent cold, all with liquid water hidden beneath frozen surfaces, all heated not by the sun but by the worlds themselves, quietly, relentlessly in the dark. We drew the habitable zone as a ring around a star. We may have drawn it in the wrong place entirely. If TRAPPIST-1G has an internal heat source and held even a thin atmosphere, then the conditions for liquid water, for chemistry, for complexity, exist in a place we assumed was dead. And we cannot go there to check. No probe, no lander, no flyby. We are 40 light-years away, reading its warmth from the faint infrared signal it leaves behind as it passes its star every 13 days. The James Webb Space Telescope is the only instrument we have. And it is telling us that the dark side of TRAPPIST-1G is alive with something that the smartest teams at NASA and the ESA cannot fully account for, something moving, something warm, something that should not be there. So here is what I cannot stop thinking about. If life found a way on TRAPPIST-1G, not reaching toward a star but feeding off the planet's own fire, deep inside a world in permanent night, would we even know how to recognize it? Would we know what we were looking at? Tell me what you think is down there.